we left off in lesson 1.3 on this bottom row, didn't we? And I believe in your class, I was so close to having time to doing that last one, but I also knew on the greatest integer function I needed time to talk about it. So, yeah. So did you guys, we covered logistic function, all right, yes? The fact that there's kind of an asymptote above, asymptote below, and it ranges from 0 to 1. And so that's our range, okay? So greatest integer function. Let me find a calculator here. First of all, when you write greatest integer function, you can write it like this, but it has to include the brackets, okay? It's not just y equals x. You can write it like that, or you can write it as y equals int of x, as in int standing for. Okay, so both ways are valid ways to write the greatest integer function. Now, in terms of graphing, I had some people that I saw with straight lines because they just did y equals x and dropped off the parentheses around it. It's just y equals x. I've had people say that they tried brackets because there are brackets above the what? Multiplication and subtraction sign. However, that's where you get the error, I think, isn't it? Okay, so what you need when you graph it, what we are typing is y equals int x and math menu, which the math button is under the alpha button, correct? Math menu brings up a menu that looks like such. Arrow 1 to the right to the num menu. And what do you notice partway down there? There is int. So you want to hit number 5 or arrow down to number 5 and hit enter. Except that I wasn't in my graph, was I? Whoops. Okay, but that's where it is. And you're going to do x in parentheses, and that will be it. Now, what I need to go back and do, though, I forgot. I need to be in y equals, don't I? So let me clear this off. Y equals math menu. Oops, arrow over to num, and go down to number 5. You put an x in there in parentheses. I'm going to hit zoom 6, and I'm going to graph it. And it looks like little stair steps, doesn't it? Non-connected stair steps, but little stair steps is what it looks like. So this is what the greatest integer function looks like. Now, I'm going to just do a basic zoom in, just so we can see it a little bit better. And in case you haven't caught on, to do zoom in, I hit enter, and then it doesn't zoom in yet. It says zoom in, and it's kind of asking, okay, where do you want to focus your zoom in? My blinking cursor is there in the center. That's fine, so I'm going to hit enter. And now you can maybe see a little bit more about what's happening with that graph. Okay? So it's stair steps. You'll notice at 0, 0 where my cursor is, if I trace and I go right, notice my y value stays at 0. And then at some point there, but around 1, what's it do? It hops up to the 1 line. And then at some point around 2, it's going to hop up to the 2 line, so on and so forth. So that's what your greatest integer function looks like. Now, as we draw it out, let me set up my graph here. I'm going to label up 1, 2. I'm going to label down -1, -2. And I'm going to label, I think I'm going to go ahead and label to the right 3. And I'll probably just go left 2. But what's going on here is we have lines. My first line is on the x-axis from 0 to 1. Then at 1, we jump up to a y value of 1. So from x equals 1 to 2, we have a y value there. When x is 2, we jump up to a y value of 2. And so from 2 to 3, we have these lines. You can also backwards. You have a y value of negative 1 from 0 to negative 1, a y value of negative 2. Okay, that's what the greatest integer function looks like. Now, this is a function, which means if it is a function, it has to pass the vertical line test. For each x value, there can only be one y value. And so what part of the greatest integer function here is that we have to, these endpoints. The left endpoint is always included. The right endpoint is an open spot, so like a hole, an open hole. Because what happens there is that means when x equals 1, it doesn't exist right here, but it does exist straight above it in the next line. So then at the right of this line, there's a hole here, but it does exist here. Hole here. You can also backtrack it. So the holes are always at the